Coming. Okay, come on, let's focus. Unless, does someone need to go check on her, or is she okay?
Good job yesterday.
She's okay, she's checking on someone else? Okay. All right, cool kids, here we go. How do we finish this problem that we got stuck on yesterday? We didn't get stuck on, we ran out of time. We were so close. Look, the end of the notes. So close. Do we want to add up all the different ways that it could have one or more faulty units? And the answer is no. So what's the only way that it does not have a faulty unit? If they're all good. And the idea of a complement says, hey, we can find the probability of it having at least one faulty by taking the one way that doesn't happen, which is if they have all good units, and subtracting it from 1. But how do we find the probability that all the units are good that they get? The first unit they have is good, the second unit they have is good, the third unit they have is good. How do we do that? Is it a struggle? Fundamental counting principle? What are the chances of having a good one? 999 over 1,000. So the probability of having one good one, 999 over 1,000. What's the probability of getting two good ones? First one good and second one good. Oh, wait, you guys. And. What do we do with ands? Times. Oh. So what's the probability of having the first one good and the second one good and the third one good and the fourth one good and the fifth one good? Isn't the first one good? And the second one good? Hopefully I don't have to do this much longer. And the third one good? Okay, those stop me, please. It's getting tiring. And the fourth one good? Why? What can we do instead of all these blanks? Because we have 196 more to go. Yeah. What power are we going to raise that 999 over 1,000 to? Yep. All 200 units. All 200 blanks need to be filled in with that probability. So, what's 1 minus 0.999 to the 200th power? Is that the 1 minus?
It's going to be like 0.01, like 1%, 0.1%.
Probably not 0.1%.
That's 18.1%.
So 0.181,
Yeah.
which is which symbolizes the probability of them getting at least one. So guys, did we count up all the different ways of having at least one faulty? No. Did we figure out the one way that it doesn't happen? Yes. And what did we do with that probability? Why did we do 1 minus? What's this called? 1 minus? The complement. We said the complement to getting at least 1 is all good, so if we do 1 minus the probability of all good, then we get the at least 1. Now, if you guys want, just real quick, and I'm not going to take a lot of time on it. If we were to figure out the different ways of having at least one faulty unit, we could go ahead and think about it as 999 for 199 of them, and then 1 over 1,000 for one of them. Or we could think of 999 over 1,000 for 198 of them, and 1 over 1,000 for 2 of them. Or we could, hey, what does this kind of remind you of? One of them's counting down, as the other one's counting up. Hey, it's like a binomial. Oh, that's funny. What's the coefficients of the binomial theorem? Aren't they NCRs? Oh my goodness, probability and binomials all relate? And the answer is yes. All right, cool kids, here we go. Section 9.7. Can I go ahead and put the evens up on the board for us to start checking? Yeah. Let's check homework first.
You can ask for 31 also.
31 is a question.
Really try to understand Calc jackpot.
Okay. Section 9.7, number 2, sample space. Number 4, impossible versus certain. I think I also said guaranteed. That would have also been fine. Number 8 would be 3142. 3142. Number 20, final answer is 1/2. .44 has 2 parts. Part A, you guys could have written these as percents, I guess, if you wanted to. Or you could write them as decimals. They just decided to do them as decimals. So 0.076 or 7.6%, or 0.00069, or what would that be? 0.069%? I think and was an important one in number 44, right? How can I tell that? Yeah, it's a multiplication, right? By the ands. Number 52, the complements. Just subtract from 1, you get 0.64 or 64%. Have to go to the next page. You guys ready? And then number 60, I think is our last one. 0.81, 0.01, 0.99, or 81%, 1%, and 99%. P.S. In letter C, they use the idea of a complement. They said, what's the way? I think it was another at least question. Instead of adding up all the at leasts, they figured out the one way it wouldn't happen and subtracted from 1, which was much easier. And Luca, yours was 31? Mm-hmm. No, Lonnie, if you checked it, you can go. Are you checking on? Both at the same time. Alright, let's go check out number 31, but did you guys have anything else we need to check out? Is that the only thing? Any evens you want to see some more explanation of as to why it was what it was? You guys are so quiet today. Something happened?
I'm tired.
No?
It's been a long week.
A long week.
It is true.
Yeah. Jesse's gone today. Surprising with the play coming. Karina's gone today. Those who are supposedly coming. Okay. Alright. Alright. Just number 31 then. Both marbles are red. That one, Luca?
Yeah.
This sounds a lot like an SAT problem, huh?
Yep.
Marbles, different colored marbles struggle. Drawing 2 out of the bag. We have 1 green, 2 yellow, 3 red in the bag, and we're pulling out and not replacing. So you can't like pull one out and then put it back and then pull one out again. What is the probability? So we know we need to make some sort of fraction, right? What is the probability of pulling out both or 2 marbles that are red? Now, unlike yesterday, remember that one, guys, we were talking about the computer automatically generating? You guys wanted to use combinations and say like 5C3, and I was like, oh, we gotta split it up. What was special about that one that said the combinations were, or even permutations, that either one altogether was a bad idea? Do you remember?
You can repeat.
Because the computer can repeat. It has like this situation of 1 to 20 and it says whatever, just choose, and it could choose the same number 3 times, theoretically. But in this one, can you repeat? And the answer, well, they already said, what? Was a no. So we can go ahead and use permutations or combinations to help us because there is no replacement, like a finite number of objects.
Yeah, and that's the problem. CalcCheck used it.
Huh?
CalcCheck used it.
That's what I said, you can.
Oh.
You can. So with the computer, when it could pull out numbers 1 to 20 multiple times, it can say like, hey, 8, it works, hey, 8, it works, hey, 8, it works. It can use 8 3 times. We couldn't use combinations, permutations altogether, like 5C3 yesterday or 5P3, depending on whether or not order was important, because it could be repeated. But when it can't be repeated, we can use combinations, permutations. So the fraction says, how many marbles total do you have to choose from? 6. Do we care about what order, like first red, second? No. Okay. So 6, and we're choosing 2, right? But how many red ones specifically do we have? So out of all of those options, how many different ways out of those 3 could we choose 2 of them? That should be, because I don't think order is important, no. That
And
should be how.
That's something
it's
I'm
set
getting
up.
messed up with. They say, okay, order matters. It really doesn't. I end up using permutation, I should use combination.
Let's think about when order does matter. Order matters when it says something like this and then that, instead of saying both. We don't care what order, just both. Or like in license plates, telephone numbers, letters, order is important. President, vice president, if we're picking positions, order is important. Rolling a die, rolling a 1 and then a 6 would be theoretically a different possibility than a 6 and a 1, so that order matters. Which one? Yeah, locker permutations.
Yeah, but then CalcCheck used combination for locker combos and they still, like, you could have used, okay, there was a problem that was,
Yeah, which one is it?
you have 40 numbers. Let me see.
I think I actually remember this problem.
Yeah, it's like, you can use, it's a permutation of 40 numbers.
Does anybody know which one he's talking about with the locker?
Maybe it was 9-6.
License plate, true, false, airport. Oh, combo lock?
Dude.
I'm surprised you guys didn't ask about that one.
Because also, it was considering that you could use the same number 3 times. And like,
Oh, I remember that one.
that doesn't make a lot of sense. So it is the 40 times 39 times 38.
But it was 40, 40, 40?
Yeah.
Yeah, 40, 40, 40.
Sorry.
And then that one seems
It doesn't
be
seem to make sense, you can repeat, I think when they said, oh, they didn't even say, they said inclusive. The idea is with this one, could you though theoretically have a locker combo be all 3 of the same number?
Yes.
Yeah, because you would go to the number once,
Then you go.
then you would go to that same number,
And then you go to it again.
and then,
You go back. Oh.
that'd be weird.
So you
No,
go
it's
to
like
the
you go to the number once, dum dum.
Then you go
But you
past.
have to go past it, remember? Like you have to go to it, then you have to go past it, but then how to go straight to it?
See, it doesn't.
It doesn't make sense in real life.
Yeah.
But what they were saying is theoretically it could be written down with 3 of the same, but I don't know how it would work in an actual combo lock. I agree with you, Luca. But if you think about, is it called a combo lock? You guys know like on briefcases, maybe you haven't seen this, or even suitcase locks, how it has the 3 little dials?
Yeah.
That's another way of thinking of a combo lock in that you could have 3 and then 3 and then 3. So maybe it's a different one than the actual locker combinations you guys have. So maybe they just had mine a different lock.
And
That would make more sense.
why would this not be permutation? Because in the end, the order matters.
But
You could have a 9,
Remember what I
1, or
said?
1, 9, 1.
when you can repeat, it's technically not a permutation because a permutation counts down. So when you were counting down, that was a permutation because you thought it couldn't be repeated. But since, as you pointed out, this one they thought it could be repeated, like the dial locks, then it wouldn't be a permutation anymore because it's same, same, same. Permutation is a factorial over another factorial, so it counts down. It says it cannot be repeated.
if it was a permutation, would I do 40
39.
P? Would
Oh,
I do 40
P3.
P3?
Which is 40, 39, 50. See? Yeah. So the key for the using of the permutation or the combination is whether or not the object can be repeated. That's a good way of summarizing. You guys didn't say you had any other questions. I'm kind of worried by that, I won't lie. So I'm just gonna get you guys started on your review ASAP, because some of you maybe are still trying to finish up old homeworks. And then I can be, if you need a book, go grab one, just kind of, they're falling apart, be nice to them.
There's one more.
If you run to your locker, you can run to your locker, you guys know on review day.
Who's
you can
gonna
see your
run?
book. But if
Who's
you have a
gonna
question, please allow me to explain it to you, because these things are kind of hard, right?
Run.
As many talks as we can.
Good job. Good job again.
I didn't say I'm not talking to you, just came back to class because I was gonna like see what the examples, but now we took the I know she was upset this morning, so I don't know. Yeah, because I was in class. So I don't know if it just was like a combination.
Did she come in and put her stuff down, or is that all yours, Luca?
Sorry?
Is that your stuff, or is that?
That's mine. Yeah.
Okay, so she hasn't come in at all?
No.
How do I know if it's what?
The fundamental counting or the,
This is the one he was mentioning.
yeah.
So in the combo lock, you say you can't or you can? Yeah, you can repeat, and because you can repeat, you wouldn't use permutation since permutation.
Like, how do I notice it's permutation? According to the
Permutation would be if it said something like, the letters or the numbers can't be repeated. Because then if the numbers couldn't be repeated, it would be 40, 39, 38, which would be 40p.
And then when you're trying to solve that, you use 40 factorial over
36.
It's just reminds me of ethics, you know?
the ladder.
You could do, like, in these ones, you're using all the letters, but there's only a set number of letters. So you can't use A like 7 times, right? You only use it twice.
Yeah, my house, like,
Instead of
my
just
dad
being
got me for me.
7,
and,
6,
like,
5,
I
3, 2, 1, or 7, 8, 7. But we have to divide by the base. That's a special case where we say, wait a minute, but if we switch the two A's, it's the same, arrangement, the same word, does that make sense? So then to repeat an object, we have to divide by the base. So we can do
We
seven.
only divide by the ones
How many
that
sets are seven? So 2 A's, 3 E's, so 2 factorial.
so I don't need to write that.
No, technically it'd be like 7 E7.
He's OCD, right? I know that.
Like, that like turbo.
So it says 11, choosing 7, but if we were to rearrange these two, it doesn't matter, and if we were to rearrange these two, it doesn't matter.
Luca.
For the facial recognition.
Yeah, recognition.
Why is that like you have to?
Because we can't use permutation, since it's not one selection that we're picking from, it's always different selections. So it's like 195P1.
So
It's not
it's
P1.
combination, like the name principle? Or is it?
It's not really even combination, because we're just choosing one of everything, which is why we just stick with the numbers of 195. And, you know, so it's like fundamental times, yeah, we're choosing this, these are how many options, we're choosing this, these are how many options, we're choosing this and that, and that, and that, we're just multiplying that.
And the balls from the national balls. I just did like 2 records with the whole bag.
Yeah, but you have to do that
Can I
twice, right? Because the probability of getting that the first time,
is 2 out of 6.
uh-huh, So the first red ball, you get 2 out of 6, but then the next red ball would be 1 out of 5.
No, I'm rushing. That counts.
Because the chances are 2 out of the 6, and the chances are 1 out of 5.
Oh,
That's another way of doing it. That one. Sorry, Jess, I didn't pause my video.
It's okay, can I